Now that we have the theory down, let's test how a solenoid valve changes the direction of flow of a fluid as a way to control the actuator. For this test, we need a regulator, single solenoid valve, power supply, and pneumatic cylinder. First, I'll run the test with the coil tester's power off. The fact that the power is off means that there is no electric current flowing through the solenoid valve coil. So, inside the solenoid valve, the spool and piston are probably pushed toward the plunger due to the spring and the force of the compressed air. That means, as we learned earlier, the compressed air is being supplied through the first and second ports and being released through the fourth and fifth ports. As you can see, the air entering through the first and second ports go toward the rod of the double cylinder to move the rod backward. The air in the head side has been released through the fourth and fifth ports. Now, let's turn the power on and see what happens. Current flows into the solenoid valve and the plunger gets pulled. The compressed air entering into the hole between the plunger and piston pushes the piston and spool toward the spring. This causes a change in the direction of flow of the compressed air. The compressed air gets supplied from the first port to the fourth port, and the air inside the cylinder gets released through the second and third ports, causing the rod to move forward. Then, let's repeat the process of turning the power supply on and off. We just saw how a solenoid valve changes the direction of the airflow and controls the movement of the actuator.